All right, the instructions here say find the exact values of the 5 remaining trigonometric functions of theta. So remember, the first thing we need to do is figure out what quadrant we're in. And then we can worry about the, whatever we have, what we don't have, and what we need to solve for. And so when we go to first quadrant, deciding what quadrant we're in, we are going to think about our coordinate plane here. All right, so we have this guy. And they have told us that cosine is what? What is cosine, positive or negative, according to what they've given us? Cosine is negative, all right? So they've given me my cosine. They're telling me it's negative. Cosine is your x value. So on your coordinate plane, where is your x value negative? Which quadrants?
3 and 4. Is that 1 and 2 or 2 and 3?
2 and 3.
Oh,
Okay, 2 and 3. All right, that's where my cosine is negative. So that's where my cosine or my x value is negative. They have told me something else. They have said my sine is also negative. So then where is my sine negative? Where's my y value negative?
The bottom left corner.
Yeah, so my sine is negative here and here. So which quadrant am I in?
3.
I'm in my third quadrant. All right. So I now know that I have negative sine, negative cosine, tangent is sine over cosine. So tangent here is going to be positive tangent, negative sine, negative cosine. Okay. Now if I have cosine, then I have my x over my r, right? Cosine is x over r. Right? Or, adjacent over hypotenuse, r being the hypotenuse, okay? So if I have my x and I have my r, I need to find my y, all right? So for Pythagorean theorem here, x squared plus y squared equals r squared when we're doing, trigonometry. So I have negative 12 squared plus my y squared, which I don't know, equals my 13 squared. 12 squared is what?
144.
Plus y squared equals 169. Hopefully you know that one. Subtract, so y squared equals what? 25. We're going to go with that. So y equals 5. Specifically, my sign is positive or negative? Negative, according to what I just said, okay? So now I have my x. My x is negative 12. My y is negative 5, and my r is 13. And I can do my trig functions. Sine is y over r, negative 5/13. Cosine they gave me, right? Tangent is y over x. So negative 5 over negative 12. I need to simplify that to positives, all right? Cosecant is just my reciprocal. So negative 13/5. Secant is just my reciprocal. Negative 13/12. Cotangent is just my reciprocal. 12 over 5. And those are my 6 trig functions for that one. So for this one, they want the exact value of the expression. If it's undefined, write undefined. All right, so this is where we're gonna use reference angles here. So again, we are gonna go to our coordinate plane. And we are going to think about what 5 pi over 4 looks like. All right. This is negative 5 pi over 4. So it just means I'm going clockwise instead of counterclockwise. All right. So I want to think of this in terms of pi over 4. So this is going to be 0. This is going to be 4 pi over 4 because that's pi, right? And then I'm going negative. So if I'm going this way, this is going to be negative pi over 2, or in terms of pi over 4, negative 2 pi over 4, right? Then I get to negative 4 pi over 4 here, right? I'm still not at negative 5, okay? Negative 5 pi over 4 is going to be in this quadrant right here. And it's actually going to be my 45-degree angle because that's what pi over 4 is. And so if I kept going around, this is where I would get to negative 5 pi over 4. All right? How far away is my negative 5 pi over 4 to my 4 pi over 4? Just 1 pi over 4, all right? When I'm looking for reference angles, I want my angle to my closest x-axis, okay? So that's why you need to figure out what it is in terms of that denominator so that you can subtract and figure out what you're left with. So pi over 4. So this is the reference angle for pi over 4. So I am going to take my tangent of just pi over 4. It will have the same tangent. The only thing I have to determine is it positive or negative, all right? So then I'm going to look at my xy. Is my x positive or negative in my second quadrant?
Negative.
Negative. Is my y positive or negative in my second quadrant? So I have a negative and a positive here. So is my tangent going to be positive or negative?
Negative.
It's going to be negative because I have a positive over a negative. So then I have to know the tangent of pi over 4. This is one that I should know, have memorized because this is my first quadrant. All right, so in my first quadrant over here, I have pi over 4. I need to have this guy memorized. The sine for pi over 4 is square root of 2 over 2. The cosine for pi over 4 is square root of 2 over 2.
45 degrees.
Yes, 45 degrees. So my tangent is my sine over my cosine. What's anything divided by itself? 1. So the tangent of pi over 4 is just 1. The tangent then of negative 5 pi over 4 in the second quadrant is negative 1. Same thing here. They want us to find the cosine of 7 pi over 4. So the very first thing we're going to do here is we are going to figure out what the reference angle for 7 pi over 4 is. I can tell you, if it's pi over 4, if it's anything over 4, your reference angle is going to be pi over 4. We just really need to figure out what quadrant it's in, okay? So this is going in the order that it should go in, so we're going counterclockwise. So this guy right here is 1 pi over 4, right? This is 2 pi over 4. This is 3 pi over 4. This is 4 pi over 4. This is 5 pi over 4. 6 pi over 4, 7 pi over 4. All right? This is actually on your unit circle. So if you've completed your unit circle by this point in the quiz, you actually have 7 pi over 4 written down. We know that every pi over 4 is square root of 2 over 2, square root of 2 over 2. In this case, though, one of these is negative. Which one of these is negative? My x or my y?
Your y.
My y. So that guy's negative. All right? However, it wants my cosine of 7 pi over 4.
X over
So it is just my x. And remember, it's over 1. So that's going to be square root of 2 over 2. My reference angle here is pi over 4. So I am still pi over 4 away. I'm 1 more pi over 4 away from my x-axis. So I know it's going to be a square root of 2 over 2. I just have to determine whether it's positive or negative. Cosine in the fourth quadrant is positive. So that's my answer. So if I am converting degrees to radians and radians to degrees, I am going to use my pi over 180 or my 180 over pi, depending on what I have and what I need to convert. So the first one is 75 degrees. I want it in radians. So what am I going to multiply it by? Pi over 180. Pi over 180. So I'm just going to take that, multiply by pi over 180. You do want to reduce. So for these, you want to make sure that you simplify. You don't want to leave it like this. So we want to, what goes into both of them, you can start with like a 5 and say, okay, so 5 is going to be 15 and 5 here is going to be what? 36? What's that news? And then I'm going to reduce by 3 again, and I can say 5 and 12. And so then my final answer here would be 5 pi over 12, because I can't reduce it anymore.
Gosh, I love
By the way, this particular one is on page 233, converting. All right, so for the next one, I have it in radians. I want it in degrees. So I'm just going to flip it. Instead of pi over 180, I want 180 over pi. And again, I want to reduce this. The pi's will cancel. And the 2 will cancel with the 180. I do want to pay attention that this has a negative there. So -3 times positive 90 is negative 270 degrees. And so that would be my answer there. For these, draw an angle with the given measure in standard position. Then give a positive and negative coterminal angle for the given angle. So the first thing they wanted is in standard position. So that means I'm going to start here. And this is negative, so I'm going to go this direction. This is 1 pi over 4, 2, 3, 4, 5, 6, 7 pi over 4. So that would be my angle, 7 pi over 4, negative. All right? So that's my first part of this, is just sketching it. Then I'm going to take that negative 7 pi over 4, and I need coterminal angles. So I need to add 2 pi to that guy, and I need to subtract 2 pi from that one, and that will give me my coterminal angles. All right? Now, keep in mind you need a common denominator. So 2 pi, if I want it as a 4, is going to be 8 pi over 4. So 8 pi over 4. And then I'm just going to subtract. Negative 7 plus 8 is 1 pi over 4. And negative 7 minus 8 is negative 15 pi over 4. Those would be my 2 coterminal angles here. So I've sketched it and I've given 2 coterminal angles. Right. Well, yeah. So I'm going to start here, and if it's coterminal, I need to go a whole entire circle, which means I need to add a whole circle, or I can subtract a whole circle, but I need to end up at the same point. So if they want a coterminal, it means you're ending at the same point. In order for me to end at the same circle, I have to go a complete circle. Complete circle to end up at the same point.
So do we always use 2 pi?
So when it's radians, I'm going to add 2 pi and subtract 2 pi. We're about to do degrees, and we'll use 360 for that one. So for 135, this is positive. So for this next one, I'm going to go positive 130. And so this is so we're going to go 90 here. This is 180. So I know it's going to fall in my second quadrant. Specifically, 135 is a 45 is what it is, right? So this is 90. If I add 45 more to it, I will end up right here at 135 degrees. So there's my sketch. All right. And then to do my coterminal angles, I'm going to take 135 degrees. And since this is degrees, I'm going to add 360 for that guy. And for the one that's negative, I am going to subtract 360. And so for this one, we just add and subtract. So we're going to get what? 495 in the positive. And then for this one, we're going to get a negative angle, which is fine. Negative 225. For this one, arc length. We talked about arc length is on page 235. So arc length is on page 235. And sector is on page 237. So you do have to know your arc length. Formula S equals R times theta, theta being in radians. And for sector, the area of the sector is 1/2 R squared times theta, also in radians. So for this one, if I'm finding my S, I'm going to say R 10 times my 120. However, that is in degrees. So I'm going to need to multiply that 120 by pi over 180. All right. And you can simplify because you do want to leave it in terms of pi here. I don't think the answer, I think it wants the exact length, so just leave it in terms of pi. But you can cancel stuff out, so you can cancel your zeros here. You can cancel, what goes into both of these. So you can start with little if you want to. 6 goes into 18, 6 goes into this right here. If you can't reduce it anymore, then just multiply 20 times pi. And then on the bottom, you're going to have your 3. And so that would be your arc length there. For sector, same thing. We're going to say 1/2 R. My R here is 9. Make sure you have radius and not diameter, because some word problems will give you diameter. times your degrees, 225, but I need it in radians, so pi over 180. All right. And you can simplify this as well. So we have 1/2 times 81 times 225 times pi over 180. I think this one ends up being kind of big. So 9 goes into both of these. 5 goes into both of these. And I think that's all we can do. So then just multiply across. 9 times 45 is going to be what? Okay, that's right. So 9 times 45 is 405 pi over 8. And this is in yards, so this is going to be square yards. This one up here would have just been in miles. It's not squared. And that would be your answer. A Ferris wheel with a radius of 15 inches is moving at 3 revolutions per second. What would the linear speed be in miles per hour? So first of all, you have to remember your linear and angular speed. That is page 236. Linear is s over t, and angular is theta over t. They want linear. So remember s, though, from our other pages, theta times r. So I have to first find theta. Theta, remember, 1 revolution is 2 pi. So if 1 revolution is 2 pi, then I have to take my revolutions. My revolutions times 2 pi will give me my theta. So here my theta is going to be 6 pi. All right. My radius here is 15 inches. So to find that s piece of it, I have to take my 15 inches times my theta, 6 pi, over my time, and that's 1 second.
What kind of reversal is this?
All right, and they want it in miles per hour, and I have it in inches right now per second. So I have it in inches per second. I need it in miles per hour, so I need to convert. There are how many seconds in an hour? 3,600 seconds in 1 hour.
How many seconds were in an hour?
All right. And for inches, I'm going to do it twice. So I'm going to say 1 foot is 12 inches and 1 mile is 5,280 feet, if we don't know that yet. All right, so just multiply across in your calculator. 15 times 6 pi times 3,600. Take that whole group and divide by 12 times 5,280. And I think it should be 16 miles per hour. So your theta is always your revolutions times 2 pi. So you have to solve for each of these to be able to solve this. You need theta and radius to solve for s. You need s and time to solve for v. You need theta and time to solve for your angular speed. This is on the point, any point on the coordinate plane. So they have given us our x, they have given us our y, we need our r, which is Pythagorean Theorem. X squared plus y squared equals r squared. So when I do this guy, this just ends up being 2 squared, 4 times 3, so 12 plus 2 squared, which is 4. 16, the square root of 16 is 4. Remember, your radius is always positive. So now I can do all of them. Sine is going to be my y over x, cosine, etc. So I can do all of these based on those. It's asking for cosecant. Cosecant is my reciprocal of my sine. So cosecant is going to be r over y. So my r is 4, my y is -2 here. So my cosecant should be -2. So page 242 will give you your y over r, x over r, y over x. All right. For this one, we need to figure out which one we're in, which quadrant we're in first. So if I look here, My cotangent is positive. That means my x and y are the same. And my cosine is positive. So where is my cosine positive and my cotangent positive? Cosine is positive and cotangent is positive, meaning my sine is positive as well. Where are sine and cosine positive? Which quadrant?
X.
First quadrant. First quadrant. Sine and cosine are positive. All right. I have my cotangent. So I have my x over my y. Yes, cotangent is x over y. We're all the way into page 248 here. So if I have my x and my y, I can solve for my,
R.
well, and yeah, so basically solving for my r here because, and actually we don't need this page just yet. All right, so I have 1 plus 25 equals 26. My r is square root of 26. And then I can give my other just based on that page, right? Based on page 242, I can do my other ones there. All right, it's just y over r, x over r,
That's our class.
y over x.